Okay, now I want you guys to do this problem. It's very similar to other problems that we've seen so far. So I'm going to pause the video, then I'm going to go quickly through what the book says on this slide. So pausing now, ending pause, coming back. So I work this using New Octave also. So we need to get the total impedance of the network, which is given by the 2 ohms plus these two in parallel with each other. And we can get the current equals the voltage divided by that impedance. And crunching the numbers, we get down to here, and I want to go to New Octave. I wrote a script in New Octave to do this. So let's see the script. So Z, I can put in the complex numbers in Z and then find the angle and the magnitude and angle. So I'm going to run it and go back over to New Octave and see how it runs. It runs this stuff. I copied and pasted it into bigger letters here so that it's easier to read. Voltage, I'm using the less than symbol to be the angle. 12 at the angle of 60. The complex numbers for Z, and then converting it to angle, magnitude and angle notation. And what did they say over here? 4.47 at negative 26.6. 4.47 at negative 26.6. Okay, total current is going to be total voltage, which is this, divided by Z. And let's see what they say. 22.68 at 86.6. 2.68 at 86.6. And the power would be twice the magnitude of the current squared, that'd be I squared times the resistance, all divided by 2, or 7.2 watts is what it works out to be. So let's keep going with this, 7.2 watts. Now, to get this part, we need I2. And let's see, editor, go back. There we go, okay. They're using a current divider. That is, this impedance divided by the total, the sum of these two gives you a current divider. So you can get I2 from the total current. And you get these complex numbers. And let's go back to the editor. I2 is the total current times that, the right hand impedance divided by the sum of the right hand and left hand impedance. 1.90 at 41.6 degrees. And let's see what happens here. 1.90 at 46.1 degrees. And keep going with this. Power is 1/2 times the resistance times the 1.90 squared. Power 1/2 resistance times the 1.90 squared. And so here's what I actually did, but here's what I wrote down. So I need to change this part of my editor right here. Resistance times I squared divided by 2, 1/2. There you go, 1/2 resistance I squared. And they didn't calculate it, I did. Oops, let's go back to this. And I get 7.2 watts, which is kind of weird. Wait a minute. The power through the 2 ohm resistor is 7.2. That's the total current. Less current, higher resistance through here. It turns out that I2, this right here, the magnitude of I2 is the magnitude of I1 divided by the square root of 2, which is why they're identical in this case. Okay, you'll notice the impedance are equal in magnitude on either side. Moving on. Okay, you know how to do current divider. Same sort of problem right here. Not much different than what we've seen. So I'm going to quickly go through the slide, just run through what they do. And of course you can download the handout and see it. See the same thing. Very similar here too. Instead we're using inductors. We got two voltage sources, so let me do this one. So just a reminder down here, what average power is, it does have a phase angle right here. And resistors, you can use either one of these two formulas. Magnitude of current, magnitude of voltage, watch out for that. In DC circuits, remember power equals Ri squared, or V squared over 2R. Excuse me, V squared over R. The 1/2 is missing. The 1/2 is here because we're talking magnitudes. We're not talking like it's constantly high. This is the peak that it reaches. Okay. So I'm going to zoom through this kind of quick. I2 is just the voltage divided by the resistance here. Power through the 2 ohm, just using 1/2 Ri maximum squared, 36 watts. Power through the inductor, 0, because the current and the voltage are 90 degrees out of phase. So to get the total, to get how much this power supply is absorbing or supplying and this power supply is absorbing or supplying, we need to know I3. And we need to know I1. We got I2. I2 is just this voltage divided by 2. But we don't know I1. Okay, so let's go for it. I3. It's going to be the difference between these two voltages divided by the impedance of the inductor, right there. And crunching numbers, you get this. I'm not going to check it with new octave. I trust them. It looks reasonable. Let's put it that way. It looks reasonable. Okay. And that's I3. Did we get I2 already? Yes, we did. There's I2. Oops. Okay. And the power supplied by the 6-volt source then would be 1/2 times the 6 times the current and times the cosine of the difference between the angles between them. 18 watts. Okay, that's pretty easy. Now, I1 is, we have I3 and we have I2, so we just can add them together to get this result. The power then is just 1/2 times the maximum voltage, maximum current, cosine of the difference between the angles. We have a negative sign here, by the way, so that'll add up. 54 watts. So we have 36 watts being dissipated in the 2 ohm resistor. We're presuming 18 watts is absorbed. That is, power is going into this guy. Notice the direction of the current. Power is going out of this guy, of the 12-volt source. So 18 plus 36 should equal 54. And indeed it does. Voila. That's the end of this one. I'm going to make, go look at the slides. You got, okay, we've seen enough examples. You do the stuff, go look at the slides and do them. I'm going to go to the next topic on the, in the videos, but I'm not going to do any more similar problems.